Let's talk about the merge case sorted list. So you are given an array of k linked list lists. Each linked list is sorted in ascending order, so you have to merge every single node into one list. So this idea is pretty simple, so I'm just going to draw it and you'll be able to understand it. So I'm going to pull every single node out, but only the first one in every single list, right? Then I will have to add into the PQ. So I will have a PQ, and priority queue is sorted, right? So from smallest to the greatest. So I will just compare every single time when I pull and I add, and I will just have to redirect my next pointer for every single node. So first of all, I will have to traverse. So I will traverse every single node. I mean the first one in every single list, right? So I would say list, node, and the first one, right? And then in the list, right? I'm out of space, but you understand. And then I will just add into the PQ, right? Then after I finish the first for loop, which is adding every single first node into the priority queue, right? I would just have to keep polling from the PQ, and then when I poll, I have to check is my current node is null or not. If this node is not a null, then I will just have to add the next pointer. Add the next node to my PQ, right? And then just so on. And this will be pretty much the easy solution. So let me just code it. So at first, I'm going to say if the list.length is equal to null, or it's equal to 0, or the list is actually equal to null, I will just have to return null. Right. So I will have a priority queue, and I'm going to store in this node into the priority queue. So new priority queue, and I'm going to compare every single time. So I will have an A, B, and then A double minus B double, right? And this will be pretty much it, right? So I will just traverse every single first node in every single list, right? PQ.add first node, and you just have to be careful if the first node is equal to null, right? You don't want to add into the PQ, right? Because when you traverse the list, maybe one of the lists is null, and then you don't want to add into PQ, right? So this will be pretty much it, right? So I have a pointer. I should have a pointer where I have to point to my sorted list, right? So I'll have to create a list node to actually store my first sorted list, right? So could be dummy, could be head, doesn't matter like which one you want to use. But when you want to return, you want to return the first one, and then later on, this is definitely sorted. It could be sorted like this, right? And I'm going to just write it. So while PQ is not empty, every single first node is in the list, right? In the PQ, sorry, in the PQ, right? So while PQ is not empty, so this means something is still in the list, right? Or in the PQ, right? And I will have to create a list node. I will have to head equal to new list node. This will be my moving pointer for the list node, and I have a dummy. Dummy is actually equal to head. So when I return, I will just return dummy.next. You don't want to return dummy. This is because dummy is actually equal to list node 0, and I just have to move my head. So head.next is actually equal to pq.pull, right? So I will pull the first one out, right? And when I pull the first one out, I will have to check if head.next sorry. Before I continue, I need to reset my head to header next. So header next will become like this. Let me draw it again. Draw the picture again. So head is actually equal to 0 at first, and header next is point at 1, and I will have to check 1.next. Does 1.next is null, right? So I will just have to reset my head equal to header next. So I'm currently at list node 1, right? So I will have to check if 1.next is null or not, right? So I will say if header next is not equal to null, I will just add into the PQ and so on, right? So you will just keep polling, keep adding, keep checking, and then just until the while loop is empty. I mean PQ is empty. Then you return dummy.next. And this will be pretty much it. So let me run it. And here we go. So this question is pretty easy. And I would like to talk about the time and space complexity. So this will be what? This will be actually k log k, right? So k is actually represent. I'm gonna write it over here. So k is actually represent the length of list. So I will only have to pull every single one out of the list, right? So I pull one out of list, pull one out of list, and I pull one out of list, right? So in this case, you only need to pull 3 out of the list. Then you have to compare. Then when you compare, you add, right? So at least k log k, right? But how many nodes you have to add into PQ? It should be all of the node, right? So this will be n k log k. This will be the time complexity. And then for the space complexity, you only need to add all of k nodes, right? In this case, you only have to store 3 nodes in the PQ. So this will be all of k in the space, and this will be nk log k for time. So be aware, this is the time and space complexity, and this will be a solution. And if you like it, subscribe and leave a comment, and I will see you next time.